You're watching EarthSky. I'm Deborah Byrd, and I'm here with C. Alex Young, who is a heliophysicist at NASA Goddard. Alex, hi.
Hey, it's good to see you.
It's so good to see you. um, Tell us what a heliophysicist is.
Well, heliophysicist is someone who studies the sun and the sun's interaction with everything in the solar system. But it's actually even broader than that. It includes things like the interaction of weather in the Earth with the upper atmosphere. So it's a very broad field and really exciting. My specialty is really solar physics.
Right. So you're a physicist who studies the sun. And in
Exactly.
particular, you mentioned weather in the upper atmosphere. So space weather, is that what we're talking about?
Well, actually, I was actually talking about terrestrial weather because it turns out that terrestrial weather sends waves up into the upper part of the atmosphere, the ionosphere, which is where space weather comes in and connects with Earth's. So terrestrial weather actually influences space weather and the space weather environment, which is a relatively new finding.
Well, so that is cool. And the reason I mentioned space weather is that we've had a lot of space weather. We've had some heavy space weather here recently, and that's because the sun is near the peak of its 11-year cycle. This 11-year cycle in the sun, and this 2024, we're at the peak or near the peak. I keep thinking we're past the peak, but then it just keeps getting more intense.
Oh yeah, we've probably got plenty more to go over the maybe the next year or so.
Oh, awesome. And so, what that really, the sun's been really exciting this week, and I want to talk to you about that later. But the super exciting sun news this week is that there's a new Van Allen belt. So tell us about that. So usually there's two Van Allen belts, right? And tell us
Right.
what those are.
Yeah, so usually there's an inner and an outer belt, and so the inner belt somewhere starts about 1,000 kilometers up, maybe 600 miles or so, and goes up to about 12,000 kilometers, about 7,500 miles, and then the outer belt is about let's see, about 8,000 uh, miles up to maybe 37,000 miles. And so the reason that we have these belts is because the Earth has a magnetic field and it's relatively complicated. However, its basic structure is what we call a dipole, which is the same as a bar magnet. So it has a north and south or a positive and negative depending on how you want to label it. And so the magnetic fields come out of the poles and then they go back around to the from the North Pole to the South Pole. And so these magnetic fields are relatively strong. And what they do is they trap particles. And when I say particles, I mean things like electrons, protons, or even bigger things called ions, which are basically these are the building blocks of atoms. But when you have an atom that you excite enough by like heating it up or hitting it with a lot of light, those constituents break apart. And so electrons, protons are what's called a charged particle. Electrons are negative, protons and ions are positive, and they respond to magnetic fields. And they spiral around magnetic fields, and depending on the charge, they go one direction or the other. So the magnetic field of the Earth acts like a big bottle. They call it a magnetic bottle, and it traps certain particles of a certain energy, okay, of a certain speed. And there are these two belts contain different mixtures of these particles. So the inner
Let me show
belt,
an image. Let me show an
yeah,
image. We do have that
yeah,
image that you and I just talked about.
sure.
Oops, that did not work. Okay, let me try again one more time. No? Okay, we're not going to show an image.
Okay, well, that's too bad. But I know the image you're talking about. Basically, it's an image that it's a simulation of these magnetic fields, and it shows all the particles spiraling around them.
Right. So
Um,
what if you could picture the image in your mind, like what the image that I can't show you looks like there's the Earth, and then there's just this incredible environment all around the Earth that consists
right.
of these electrons and protons spiraling around, and what it's basically happening is that the Earth's magnetic field is interacting with, the weather, space weather, the stuff that's coming from the sun. And with the sun being very active, there's a lot of interactions going on right now, correct?
Yeah, and so these two different belts trap particles based on how energetic they are. And the particles in the inner belt are more tightly confined and more energetic, and the magnetic field is stronger there. The closer you are to Earth, the stronger the field is. As you move away from Earth, the field drops off in value. And so the outer belts are wider because the magnetic field is significantly less, and they're a bit more mixed up, but the particles are not nearly as energetic. And then what we'll be talking about is, in terms of humans, for example, the more energetic, the potentially more damaging they are to a human being.
Right. So what we have now, the big announcement this week, is that there's a third belt. So you're talking about these two belts. There's the inner belt that's closer to Earth and the outer belt that's farther away. And a CubeSat went up and detected, in that space environment near the Earth, detected a third Van Allen belt that was not there before, and that's just a temporary belt that they say came from, and some people may remember this, the big solar storm that happened in May, where all of Earth, not all of Earth, but much of Earth saw auroras. It was just like this incredible time when, people, I mean, even here in Austin, Texas, where I am, you could see auroras. And so it was like, it was just this amazing thing. And it came from storms happening on the sun. There had been an X flare, I think it was an X 2.9 flare that happened on the sun.
Yes.
There were a bunch of other M flares. And, that stuff just came from the sun and hit Earth's magnetic field and caused these auroras and created this third Van Allen belt.
Yes, and I will a little bit more. So those flares had what associated with them what's called a coronal mass ejection. So the flares are light. The coronal mass ejection is basically a big blob of the sun's atmosphere with magnetic field. And so we had a lot of CMEs, and we had ones that there was enough of them to that brought enough energy into the Earth's magnetic system that caused all these amazing storms. And these storms were spectacular. One measure, of course, was how far south people could see it. And we now believe that that storm could potentially be many hundreds to maybe even 500-year storm.
Oh, gosh.
Yeah.
Really? That's
Yeah.
true.
Now, one of the things I can also say, though, is we do know by certain measures that even though this was a very powerful storm, it was not as powerful as the 1989 storm that took out the Quebec power grid, and it was not as powerful as the Carrington event.
Okay,
So
yeah.
those are still stronger storms.
So we always have to mention the Carrington event, the 1859 Carrington event. Every time we talk about the sun, we have to talk about the Carrington event, because that was the event where there were big storms on the sun, and the CMEs came to Earth and affected Earth's magnetic field, and there were auroras seen across the globe. But things happened, like telegraph wires caught fire,
Right,
and
right.
so, people have long said, for all the decades, the many decades that I've been in astronomy, people have said that if we had another Carrington event, if we had another Carrington level event, that it would, damage our technology. And some people like to say, oh, send us back into the 1700s and
Right,
all kinds of
right.
scary stuff, which we've had several people in the past several months on our EarthSky's live stream. We had an electrical engineer and we had a space weather forecaster, and both of them said, we're not going back to the 1700s.
Right. Yeah, that's not going to happen.
That's not going to happen. And B, there is a system in place now. Like when we first started talking about the Carrington event, we weren't as aware as
Right.
we are
Right.
today of the potential for that to happen. So electrical grids have become more kind of punch and play, where they can lift components out and put in new components. They can repair them more quickly. And also we have this great space weather hotline that when there's any strong storm, even a moderate storm that comes toward Earth, that's happening in Earth, we have the space weather forecasters get on this hotline and they talk to the power grids, and the power grids
Right.
can shed load and do things to prevent outages.
Well, yeah. So, NOAA is, and I saw it was a great interview, saw one of the NOAA forecasters,
Yes.
and, NOAA is the official organization for the U.S. And one of the main organizations for the world, actually.
Right.
But one of the things I can say is now, several years ago, 10 even longer years ago, there were several studies that were put out that estimated that it could be somewhere between several hundred billion to maybe even a few $1 trillion in damage if we had a Carrington event. However, this past large storm, we do know now that a lot of the mitigation and a lot of the procedures that we needed to have in place to prevent some big disaster worked.
Right.
So that's one of the great things about the storm is people have sort of felt like, oh, well, it couldn't have been that big because, nothing bad happened. But in fact, a lot of the things that were put in place by the power companies worked.
Right. Yes. And it's like we may have an even more powerful storm, and one of the things that's happening on the sun this week is that the solar flare that produced an X14 flare when it was on the far side of the sun about a week ago or 10 days ago, there was an X14, but it did not come our way because it was on the sun's far side. That sunspot group has now rotated around to the Earth-facing part of the sun. Correct?
Right. So that region, when it was on the sun last time, we label them. We label them AR and then a 4-digit number. And one thing I will say about that, it actually, there is a fifth number that we drop off. There's actually a 1 in front of the 4 digits, because we've actually passed 10,000 in terms of the number of these, what we call active regions. But the one that was on the sun previously was labeled AR for active region 3738. And then, as you mentioned, it went around the backside. And then the European NASA mission called Solar Orbiter, which has a bunch of different instruments, has a X-ray monitor telescope called STIX. And while it doesn't measure the exact wavelength of X-rays that the NOAA GOES spacecraft measures, which is what we use as the scale to rate solar flares, they're able to make an approximation of what the GOES class would be. And so the X that you mentioned is extreme, is the largest class, and that's where they saw the X14, which is a very big flare. We haven't had, flares that big in quite a while. So, but it's come back around. What's that?
We haven't had one in this solar
No, we have not had one that large in the
not
solar
on the
cycle.
Earth-facing side.
Correct. And then that active region, now that it's come back around, is renumbered because they always renumber them every time they come back around. It is now AR 3774.
AR 3774. Okay. And so these flares on the sun are ongoing. The event that happened in May caused this third Van Allen belt, but our power grids didn't crash. But one thing that is coming up that is of interest and that could be dangerous is that we're going back to the moon. So that's another interesting I don't want to say conspiracy theory, but I just said it, right? That
Yeah,
that we didn't go to the moon. That was a
right.
hoax. And one of the reasons they give for that, the conspiracy theorists, is that we couldn't get through the Van Allen belts.
Exactly, exactly. That is one of the main points that is brought up in conspiracy theories. And, one of the things about that is that there is a video from a scientist or from an engineer at NASA talking about getting through the radiation belts. And he's talking about it's taken out of context and used as an example, saying that he said we can't get through them. That's actually not what he was talking about. He's talking about the fact that we had yet to send the Orion spacecraft, part of the Artemis mission, through. And so at the time, part of what we needed to do was prepare, because the thing is, one of the things about the way NASA works and the way space travel works is, even if you build the exact same spacecraft that you built in the 60s, which that's not really the case, you still always want to test a new spacecraft to make sure that it's able to handle the radiation. But part of the issue is that you can go through the radiation belts. Now, they are very dangerous and you wouldn't want to spend a lot of time in them. But we know the places where you can go through where the radiation levels are the lowest, and you're traveling very fast.
Right.
And part of the thing about radiation is it's not just the rate of radiation, but how much exposure do you get over time?
Right.
That's why when there are radiation workers who do all sorts of different things, it's important to measure the long-term radiation that you're exposed to. And so the Apollo astronauts, while they did get a significantly higher dose than what you would get on Earth, they did not get a fatal or even a dose that would make them sick.
Right.
And so,
and some of them are still alive. It's 50
right,
years later, and
right,
some of those Apollo astronauts are still alive.
yeah,
So, but I mean, and I guess the conspiracy theorists would say, well, that's because we didn't go to the moon. They never went up. So it's like, you just can't win with those conspiracy theorists. Like, no matter what you say, you just can't win. But the Artemis mission, let's mention it, because the Artemis mission is not as well known as I wish it were. But the Artemis mission is NASA's new mission to take us back to the moon. And we've already had one Artemis test flight. Artemis 1 has already occurred.
hmm
And now what's about to happen is that Artemis 2 is going to be launched, and it's going to carry 4 astronauts to the moon, to circle the moon, and they are going to have to go through those Van Allen radiation belts. Do you think that they'll be going through that third belt? Will it last long enough? Because they're
third,
not going till September 2025
right,
is when they're supposed to go.
right. Well, the third belt is transient. That is, it only lasts for a certain amount of time, and it should last about a month. And the reason we know that, or the reason we expect that, is it's not actually the first time that we have seen the third belt, because there's a very famous image from the Solar Dynamics Observatory of a giant prominence erupting. You see it everywhere when people talk about this sort of stuff, and that was in 2012, and that eruption created a CME, which we believe was what actually added extra particles, creating the third belt. And the third belt is actually kind of an extension of the second belt, like a piece kind of breaks off and then forms this third belt. And at that point, that belt lasted for about a little over 4 weeks. So that's our experience with this. And because of that, we don't expect that this one is going to last that long.
Right. And so the one that was in 2012, you were involved with that, right?
Right. I mean, I was not part of the project, but I was, one of the science communicators that, it's my job to understand what people in these fields are doing. And so we did a little press conference about it. and talked about what was happening and talked about the discovery. And it was very exciting. It was a very exciting mission. These were the Van Allen probes, which were a set of two spacecraft which were designed to fly in and out of the Van Allen belts. Because one of the things that we really want to understand about it is we know particles go in, and we also know that particles can leak out. They can precipitate out. That is, they just sort of rain back down onto Earth, or they can go into the magnetosphere, which is the extended part of the Earth's atmosphere. And so there are a lot of really complicated processes that are happening, that are accelerating those particles, that are causing all of this, really dynamic phenomena. And so that's one of the things that the Van Allen probes were designed to do, is to study that so that we can understand it. Because we not only want to understand it for Earth, but other planets that have magnetic fields also have radiation belts. And that's important because, well, if we go to another planet, but it's also important for us sending spacecraft to other planets. And the most notable one is Jupiter. Jupiter has a very strong magnetic field, and it has an extremely large radiation belts that are very hazardous and are, very problematic for missions that have gone past the giant planet and studied it.
Right, and that's why the Juno spacecraft has such a long orbit, isn't it? An elliptical orbit. It's
Exactly,
in and out of
exactly.
that radiation
Yeah.
belt, trying to minimize
Yeah,
damage.
because it flies through the radiation belt. And we also have the same problem here. We have spacecraft that fly through the radiation belt. A lot of the lower Earth orbit, like the space station, for example, are under the radiation belt. But there are a lot of spacecraft that fly in and out of the radiation belt. And some of them, depending on what kind of instruments they are, they may have to turn off cameras or other types of instruments. The other aspect is there's a part of the magnetic field called the South Atlantic anomaly, which is where the magnetic field has its strength drops right over the Atlantic Ocean around South America. And so when we have strong activity, some of these particles from the radiation belts will dip down farther. And you can see spacecraft when they fly through them, you can see sometimes their images get a lot of that snow and little effect. That's from the radiation belts.
Oh, wow. Yeah, okay. So I don't want to keep you, but this is a cool thing. It's like when I heard that there was a third Van Allen belt, I was excited about that. And so, I did wonder about whether it would affect the Artemis moon mission. And I guess the answer to that is probably not, because it's not going to last all the way to September 2025, when
Yeah.
the next Artemis mission will be carrying 4 human bodies to the moon who could be affected. But they won't be, because it probably won't be there at that point. They will have to go through the radiation belts, but they'll go through fast, and they'll
Yes.
probably come back and live to ripe old ages, just like the Apollo astronauts have. So.
Right. But, also, as you mentioned, we are at solar, we are in solar max right now. So maybe they'll come again. That's another issue that we have to think about. But those are the kinds of things that NASA and NASA engineers and also working with other space agencies are, making sure we understand. Because if there is additional solar activity, that will also determine when they launch the spacecraft or what the orbit will be, because they don't want to be flying, right before a big solar storm or something like that.
Right. Yeah, for sure. And, that would be an interesting thing if they had, planned, September 2025 was here and the astronauts were getting ready to go up on their moon mission, and then suddenly there was an event like this, they would probably delay it. They would probably
Absolutely. And it has happened before. And actually, I'll add one last thing. Sort of historically, the last two Apollo missions between, is it 15 and 16 or the last two? I can never remember if it's 15 and 16 or 16 and 17. But anyway, between the last two Apollo missions, there was a huge solar particle storm in 1972 in August. The second to last mission was in April. The last mission, I believe, was in it was in farther towards the end of the year. If those missions had moved either way, the astronauts could have been exposed to fatal doses of radiation from this particle storm. So that's one of the things that they have to think about.
Okay, so I have one more question, and that is, when that third Van Allen belt does go away, will we know that it went away? I mean, do we
You
have
know,
it?
that's a really good question. You and I talked about this, and I don't specifically have an answer yet, because last time we had the Van Allen probes up for the first time that it went away, and this time was the CubeSat mission, which is a very short limited mission. So I don't know the answer to that. That's a really good question. I don't know if there are specifically other measures. I do believe there are other experiments, because we do have some observations of the belts. If we can specifically notice the third one, I'm not sure, but I will do my best to find an answer to that question.
Yes. So thank you so much, Alex. And so I've been speaking with C. Alex Young, who's a heliophysicist at NASA Goddard Space Flight Center. And Alex is also a co-author of EarthSky's Daily Sun Post. So every day on EarthSky, we present news about the sun. And this year has just been amazing. And this week has just been amazing.
Yes.
Over the past day, this morning, we were working on the post, and there were 15 M flares in the previous 24 hours. So that's pretty amazing. And yesterday there were 14.
Another 15. Yeah.
Yeah, which, in the past, if we get one M flare, we're all like excited. Oh, we got an M flare, It's a whole different universe now, because the sun is so very active now. Many, many sunspots. If you still have your eclipse glasses from April, you could look at the sun and you might be able to see some sunspots. Although I probably shouldn't say that, because I don't know if any of them are big enough to see with the eye alone. I mean, with your eclipse glasses, but are they? Do you know? If there's any?
I think you can still see some of them. Yeah, they're not any individual ones that are huge, but they're sort of clusters of them. So I think that you would be able to see them. I have definitely seen pictures of the sun taken safely, where you can see them.
Yes, and we've gotten a lot of amazing pictures of the sun recently with the huge number of sunspots on it. So that's been awesome. So come to EarthSky and visit the Daily Sun Post, and maybe we'll get an answer to that question of when the third Van Allen belt goes away, probably a month or so from now. Alex, thank you.
Thank you. Always a pleasure.
Yes. And